Hey guys, so this video is about the different types of number systems. So these symbols on the left hand side, the N, Z, Q, R/Q and R, so they're symbols that you'll see. You'll often see them in exam papers at the ends of questions where you're asked to find out X, maybe, and it says X is an element of Q, or it could say X is an element of N or something like that. So it's really important to understand the difference between them and understand which numbers are in each one. So if we just start at the top here, the first one is the N, so it's the natural numbers. So these are all positive whole numbers, so 1, 2, 3, 4 and so on. So these are the numbers that you deal with usually in primary school. So if we were to list a few more, I mean 5 would be another one, 6 would be another one, and everything above that then. 0 is not included. But we can just make some up. So 51, that would be a natural number. 128 would be a natural number. 1071, that's another natural number. Okay, so everything that's a positive whole number, so it can't be a fraction or a decimal. So that's the natural numbers. The next one then is Z. So Z is all whole numbers, so negatives, positives and zero. So if I was to list out some of those, 0, again 1, 2, and then all of the minus numbers, so -1, -2, -5, -8. Okay, everything that's a whole number, so as long as it's not a fraction really, an uneven fraction, then it's an integer. Another thing that's important is all of the natural numbers, so everything that's a natural number is also an integer. So the integers are all of the natural numbers and all of the negatives along with that. So that's important to understand. The third set here then is rational numbers. So a rational number is any number that can be represented as a fraction. So to list out some fractions, 2 over 5, 7 over 8. So those are all the obvious kinds of fractions. It's important to understand as well that all of the natural numbers and all of the integers, they are all rational numbers as well, because if I took something like 5 there, 5 could be represented as 5 over 1, which is a fraction. So 5 is a rational number as well, and it's the same with any whole number, because you can always put it over 1, and the same with the negatives. You could have -2 over 1. So all of those are all rational numbers as well. So really most of the rest of the numbers then are all rational numbers. So even if I took something like 2.3825, so that looks like an awkward enough decimal, but that is a rational number, because if I wrote that over 1, and then I could change around the form of it a little bit. So if I multiply top and bottom by 10,000, move over the decimal point 4 places, that's 23825 over 1 0. So that's the same number, so they're equal to each other. So that then is a fraction, so that's still a rational number. So 2.3825, that's also a rational number. So that's pretty much all of the numbers then. There's not that many left then that are irrational. If we look at the next one, so we've kind of dealt with most of the numbers so far. Irrational numbers then, these are numbers that can't be represented as fractions. So when you think about it, even something like this that I've mentioned here before, that still can be represented as a fraction. So it's hard to think of what might be an irrational number. So I'll give you some examples. So if we're to take the square root of any kind of number that's not a square number, I mean, if I had root 16, that's the same thing as 4, but so that's a natural number, so that wouldn't count as an irrational number. But if I was to take something like the square root of 15, so if you were to take your calculator and put in the square root of 15, you'll get 3.8729833 462, and it keeps going. So it's it never ends really. So something like that, where the decimal kind of continues on forever, you can't represent that as a fraction, because you could write it over 1, but then if you're to multiply top and bottom by something, you can't really take in all of the numbers. So that can be just left as root 15. So root 15 would be an irrational number. Another example, if you've had root 5, so if you put root 5 into your calculator, you get 2.236067977499979, and it continues on as well. So that's another irrational number. So the roots of numbers that aren't square numbers are generally irrational numbers. Another one would be pi. So yeah, pi is a symbol that we use. It's a number that we use when we're dealing with circles, but if you put pi into your calculator and press equals, it's 3.14, and then it continues on forever as well. So that's another example of an irrational number. So the last one is the real numbers. So this is just all numbers. This is rational and irrational numbers. So basically everything is included in real numbers. So the number 1 would be included, number -8 would be included, number 3/9 is included, then things like what we had up here, square root of 7 would be included, so everything. So the real numbers, you can just think that you can just try to remember that it's everything. So that's all of them then. So if we go back to start again, so natural numbers, it's important to remember natural numbers, they are all part of the integers. So every natural number is an integer also. Then every natural number and integer, they are all part of the rational numbers. And then the irrational numbers, they're kind of out on their own. They're the really awkward numbers that can't be represented as fractions. And then the real numbers, they're everything. So they're rational and irrational numbers. So it's a good idea to just think up some numbers yourself, maybe some more examples of each one, just to help you remember it.